Next, we have again 2 more speakers. Jean-Marie Alder, who is a research assistant at HESSO Valles and has been developing IT solutions to help with energy transition. Along with Jean, we have David Wannier, who is a professor at RC Lab. Oops. You can come in. Both of them will be giving a talk on applied DevSecOps for machine learning prediction systems. Modern IT systems get more and more secure over time, and new security vulnerabilities are discovered every day, including within NMN systems. This talk will present the DevSecOps approach, its challenges, and tools. I think we just need a minute. Je te passerai le... Ouais, ça va bien. Merci.
So welcome, everybody. Thank you very much for the invitation. We are with Jean-Marie, and we will present today the DevSecOps approach we have set up in our research project. What we will cover, just a short introduction about the research lab, and then we will speak about the eVIP project, the architecture overview. Then Jean-Marie will present the DevSecOps pipeline, and we will then conclude with the benefits of this approach. About ourselves, so my name is David Wannier. I'm professor at the University of Applied Science, Western Switzerland, HSSO Valais-Wallis, and Jean-Marie is member of my research team. University of Applied Science Valais is part of Western Switzerland. We have about 170 students with ongoing bachelor in business information technology. The idea of our course program is to focus on software development and data management. And we have also several certifications that could be interesting, like SAP, Cisco, but also machine learning, NIME algorithm, and also agile methodology like Scrum. We have opportunities for industry to also collaborate with us. We have practice integrated bachelor studies for Swiss-German students who can, after a high school degree, directly come to our school and do the practice part during the studies. We have also opportunities for industry to propose thesis, bachelor thesis, to explore new technologies. The lab is integrated in Institute Informatics at HSSO Valais-Wallis, and our main goal is to accelerate the energy transition using appropriate IT technologies. We have several projects, and the one here will be a local project with the ARC Foundation. We have also some Swiss projects like to improve the lighting in cities. We have Swiss Federal Office of Energy project to manage remotely from DSO local storage. And we have the chance also to coordinate the new ERANET OpenGIS for Energy Transition project following the hot maps at European level. Now about the concrete project eVIP for energy visualization, integration, and prediction. It was the base idea took place in Val d'Airain. It was to promote the image of a green and ecological region through the green mobility concept. So we have electric cars available to customers at the hotels. And that was the base idea for the project. The partners needed for this project was the DSO, local DSO, Oiken, and we have also several companies like Electroinfo to set up the whole infrastructure. We started to explore new technologies like you can discover here on the slide. So we have blockchain technology explored also by bachelor thesis. We have then the development infrastructure at Technopole, and we have the chance to improve hardware and software with a professor teaching at the campus Bellevue. The main goal is to help hotel managers to manage the energy in their hotel, especially if they add electric vehicle charging station. And for that, we need prediction. We need machine learning prediction to know how many power they can engage in this electric vehicle charging station regarding the photovoltaic production and the local consumption. The architecture is based on Internet of Things. So we see here down the endpoint, collecting the data, the Cloud I/O API level, and the application. We have also an ongoing bachelor thesis to explore the OAuth 2.0 to authenticate the users. About the software part, so we see here the GoFlex software will display the data coming from photovoltaic production and also from local consumption to drive the power at the station. We see then something important. Next part. About the persistence layer, we have here personal data. Of course, it's just a number, but when you combine photovoltaic production with a GPS position, in fact, it's like personal data. So we have a security issue, and that was the main goal for this DevSecOps approach, how to handle that. We have time series database to collect all the consumption transactions and also the metadata stored in a relational database. The prediction server is one of the main parts of these systems because he will display the available power in the next 15, 30, or 1 hour, in the next 15 minutes, so that we can manage the charging station power. In this DevSecOps approach, Jean-Marie will explain to you. He implemented the DevSecOps process on this prediction server.
Okay, thank you, David. So we're going to talk a little bit more about this eVIP prediction server on which we have implemented DevSecOps on. So basically, we created a Python Flask API, which gives users the ability to get their prediction from here. The goal of the prediction model was to predict the electric consumption for the next 15 minutes. Since here we're dealing with hotels, it was for them. As an input, we had the current ongoing power of the hotel. We also used the previous values, as well as the timestamp. So as you can see, there ain't that much inputs, so it makes this very non-intrusive system. And the output of this algorithm is to get one of the 4 levels of consumption for the next 15 minutes, from low to highest consumption. And here's what it looks like on the GoFlex dashboard, which is a dashboard available for hotel owners. Here they can monitor and visualize their energy flow, and they can also have the result of the prediction, which at the moment is green, which means low consumption predicted. It gets then yellow, orange, and red for the highest consumption. And using this result, and by setting the piloting of the electric vehicle charging station to automatic, we can automatically set the amps of the charging station to optimize the power peaks of the hotels. So now it's time for a quick question, and I just wanted to ask you in your opinion, or maybe you know the numbers, but how many people do you think worldwide have been affected by a data breach in 2021? So feel free to take your smartphone, tablet, or anything, and go to medi.com and use the provided code here, or the provided URL, and we will go to see the live results and see what are the numbers coming from here. So if we can get to the results slide while people are voting.
You don't need to register yourself. It's just connect to the menti.com and you can directly answer.
Oh, maybe we don't have the code there anymore. The code. No. Oh, thanks. So 70, 23, 11, and 98. All right. So maybe we can go back on the results and see what you guessed, or maybe you know. All right, 227 million. It's not that far from the truth. The actual numbers is that over 280 million people have been affected only in 2021 by a data breach, which makes it that you have one chance out of 20 to 25 to have been affected by a data by data being stolen or retrieved by malicious activities. So we can go back to the slide. I wanted to emphasize this to show you how important it is to make your application secure, especially when you deal with personal and sensitive data for customers. So that's why we introduce you to DevSecOps, and to give you the context and what DevSecOps really is, first we need to talk about DevOps. So DevOps is a set of practices and tools that allows developer to automate redundant but useful tasks like testing your application, building it, and deploying it automatically. And DevSecOps, it takes the same principles, but it adds a security layer throughout the entire development lifecycle. As an architecture level, what we actually put in place for our eVIP project, so as you can see at the bottom right corner, we have the Flask application running on a virtual machine and using Docker. And we've added two separate virtual machines. The first one is the CI/CD server, where we installed Jenkins and several tools that we'll cover a little bit afterwards. And the last droplet is the reports, where we've installed a vulnerability management server, where we will get all the scan reports, security reports, at one place, and we can easily manage them. So here's a non-exhaustive list of the tools we have used in the eVIP project for DevSecOps. And remember that DevSecOps is not a finite answer, and that everyone must take their own projects and see what are the different criteria and problems that you face. So you always need to adapt your solution, and you can take this as an example of what you can do with it. In our case, we needed to select different criteria, and the first one was tools needed to be Python compatible, and we also had priority for open source. So now let's go through the tools that we have used. First of all, we have an automation server or CI/CD server. We chose Jenkins, that it is one of the most popular open source tool for this kind of process. And now we go deeper into the security-specific tools that we've used. First, we have the software composition analysis, which is platform-specific. So we chose pip audit, which basically will scan all the installed packages you've installed on your program, but not only. It will also check for their dependencies and all the libraries that you may not have control over. And then we have static application security testing, for which we used Bandit and SonarQube. Bandit is more Python specific, and SonarQube works with other technologies. Basically, what these kind of tools do, they scan for your source code directly and check for vulnerabilities using known vulnerability databases. And as you can see, we chose two different, which shows how flexible DevSecOps can be. And also, why did we choose two? Is because we noticed in the results that these tools found different security issues. Then we have dynamic application testing, which will not look into the code directly, but will rather simulate attacks over on your deployed application, either staging, server, or even production, or even both. We used Z-attack proxy for this one. Sorry, I'm just going to skip this one. So here's the container vulnerability scanner. As you may remember, we used Docker images to build our application. So we used Harbor and Trivy, Harbor being a Docker image repository. And then Trivy is the actual security scanner. And I strongly recommend for anyone using Docker images or using Docker Compose to use this kind of tool. Because you may be surprised of how many vulnerabilities there are hidden inside your Docker images without you knowing. So yeah, finally we have the vulnerability scanner, vulnerability management server, which we use Defect Dojo. And the goal is to actually take all the different reports from security scans and put them at the same place. So we can easily manage them in an agile way, for instance, or we can, we can manage vulnerabilities. So here's what it looks like. So it's a very user-friendly dashboard, and you can very fast have a report and an overview of all the securities that are hidden in your code. So that was at one stage of our development cycle. And if you click on the findings, you will find a list of all the different vulnerabilities with a very detailed description, and also the place in the code, if there is, where you can find the vulnerability, as well as the severity level and tips to correct it. So here's what it is as an overview of our complete pipeline. So it starts with a regular Git push, and then as usual for DevOps, it will build and deploy in the test environment. Also run unit tests, we never forget them. And then we go to the security-specific scans. So as you can see, all of them are communicating with the vulnerability management server in order to send all the reports at one place, which makes it easier for developers to see vulnerabilities only on one place. And at this point of the pipeline, we can choose to either continue the deployment process or stop it. So we can set criteria and thresholds over where, for instance, if there are high or severe security issues, we can stop the process here. But if everything is fine, we will build the Docker image, send it to the Docker image repository, which will also have a last scan for vulnerabilities. and then we will update the image on the prediction server. So here's an overview of what it would look like on your Jenkins pipeline. As you can see, some steps have failed because they have found vulnerabilities, but we managed to find them and quickly fix them thanks to this kind of security tests. So in the end, we've seen a complete example of a functional DevSecOps pipeline. And again, since we're working with sensitive customer data, we really need to make sure that we provide a safe environment for customers. And by automating all these tasks, all these security vulnerability scans, we're able to find vulnerabilities quickly in the development process and quickly fix them. And using this technology, you can see, compared to the so-called traditional development method, that would take more time in the beginning to set up all these tools, but we get way more time in the end to actually work on the main project itself rather than fixing all the security issues at the end. So.
Thank you very much for this precise presentation. What is very interesting, we need to check the security issue after every commit. So every day we have several times the check, and that's very interesting for long-going projects. As you have seen at the beginning, you need a bit more time to set up the environment, but after you are sure that at every commit you can check that. You can find our results more detailed at the CIRED Portal 2 June of this year. We have the detail of the algorithm, machine learning algorithm used for this prediction. Just another information, we have also organized now a workshop. It will be in August 25th. Just check and book in your agenda if you're interested in a usability testing approach, because when you are doing visualization, so we are leading an expert group, data visualization and sharing. If you try to do a good visualization process, you need to integrate the clients from the beginning. So we will have the chance to do a workshop, and if you're interested in how to include a better usability testing and security, will be also linked with that, of course. Please join us in August in Zurich. It will be just next to the railway station. I think it's time for questions.
Thanks a lot for your attention, and feel free to ask questions.
Thank you.
Thank you very much for your interesting talks. And security issues are getting just bigger and bigger. So I'm curious if there are questions from the audience. From there.
Thank you. Thank you so much for your insightful talk. I agree, security is extremely important. I wanted to ask if you could maybe give us some examples as for which security breaches you could identify with this pipeline and fix, and maybe also like if you can name high severity examples and low severity, so that there is like more tangible examples that I could, for instance, translate into my work as well. Thank you.
Yeah, so I don't remember exactly all of them, but we've seen a lot of vulnerabilities that are present in the OWASP top 10 vulnerabilities, like cross-site scripting, for instance, with the Flask, Python Flask. By default, some of the HTTPS headers are not present, which might prevent some attacks.
We have had also some libraries. So when you have a project, a European project is 4 years. Of course, when you choose a library the first year, 2 years later, you have vulnerabilities. And that kind of approach can really show us as soon as the vulnerabilities are detected that you need to update the library. So that was another example. Some credential also sometimes set up by developers just to test fastly or just to have a short test, and they don't remember that they put credential in the code. So when they submit it, we stop that. For example, that was another example. Yeah. I don't know if we have some. Yeah. Does that answer the question?
We have one more here.
I can see on how you try to keep your system secure in terms of development, but how do you protect it against attacks? You've got those IT devices which may be hijacked, denial of services, attacks, actual attempts to compromise your applications and so forth. How do you protect your system from the outside world?
So we're using the Z attack proxy, which is the dynamic application security testing tool, which will actually simulate this kind of attacks, or actually known attacks that may compromise your application. So
I can see that you test for that, but when it happens, what do you do?
So we identified where the problem was. So usually for the Z-attack proxy, it won't give you a place in the code where exactly is located the vulnerability. But with the information provided by the tool, we managed to find where we could have had an issue, and then we ran back the scan, and actually didn't come back negative. So
probably wasn't clear enough, but if someone tries to exploit that in the real world, do you just let it happen because you're calm, your code is all safe, and you do nothing about it? You don't monitor it? That's the question.
That's actually a good point, and that is something that we haven't implemented on this solution. We implemented it on another project, but it is to have monitoring over your system, which is also usually a very crucial part of the DevSecOps pipeline. Unfortunately, for this project itself, we didn't put it in place at the moment.
It was just because it's a research project, and then we are not responsible for the production part, for the development issues, and then we give that to the DSO, who will implement in their own VPN the whole infrastructure. So that's also why we did not do that part effectively. We give that responsibility to the production, and that's mainly handled by the DSO, so the distribution system operators.
More questions? Perhaps I have one actually. You mentioned a lot of these open source tools that you're using in your diagnostics. When you think about the corporate environment, they go for private tools, or the tools they can buy. What is the difference between using an open source tool or something that you pay for?
Open source is not linked with pay.
No, this open source
different.
versus...
You could have open source tools that could be packaged by a company, and you need to pay. So that's also possible.
Okay.
So it's open source means it's just open to the community to improve and to add new functionalities. But there is also sometimes companies who can base the products based on this open source tool. Like Tulip, for example, application lifecycle management, they are open source, but you can have an alien who come to your company to handle the whole setup and to add new functionalities. If you want to have new functionalities earlier, you need to pay them. They will contribute, but the source code will be open. So that's very important for companies, for big companies, so that they can really rely on the source available. And if one company is not here anymore, they can manage to handle that.
Perhaps that also goes in.
It's not a black box. So that's the opposite of black box, open source, but sometimes it's not free.
Yeah, no, makes sense, makes sense. So perhaps it also goes in the direction that, the diagnostics can happen with open source tools, but for the repair of those problems, actually, you still need to work together with someone else, who goes and actually corrects the code there. And the next question, which is actually here, is that what level of security knowledge is needed to be able to work with such systems with DevSecOps approach? I mean, we have different kinds of audiences, data scientists and software engineers probably, and and then many more roles, product owners, managers, and so on. So if you think of those people.
So it's a good question. The first prototype of this DevSecOps approach was built by a master student in management of information system, and he did that as a master thesis. So at that level, everybody could reach. Bachelor level is possible also at the moment. They know how to do it. At master level, they know why you should do it.
Okay, okay. So
and
I could do it.
Implement. And as it's bachelor, they could do it, and they know why.
Okay, thank you very much. I think we have a question there. Yeah.
Hello. I was just wondering, since you also have a machine learning algorithm somewhere in there, was kind of the surveillance of the machine learning algorithm also part of the project, to avoid drift or kind of a broken model go to production or something like this? Was it included in the DevSecOps pipeline or not at all?
So currently it has not been implemented as we mainly focused our efforts on securing the application itself rather than the prediction model and, for instance, the data versioning. So I would say it's two separate levels, but yeah, we may we may implement it in the
At that, yes. Mm-hmm.
Yeah. Last question, if there is any. Thank you very much, Jean-Marie and David. We have something for you, for your hard work. Thank you very much. All the very best for the future. Thank you.
Thank you very much.
Thank you. Bye-bye.